Hey, what's going on? It's Justin Dickmeyer from EngineerInTrainingMA.com, and in this video we will review measures of dispersion, more specifically the variance and standard deviation of a set of data, population, or a sample. It is important to distinguish between the variance of a population and the variance of a sample. They have different notation and they are computed differently. The variance of a population is denoted as, so this is a variance of a population. And the variance of a sample is denoted with a S instead, and that's the variance of a sample. Now the population variance and standard deviation are the deviation among individual measurements from a population mean for the entire population. As is the case with the mean, the population variance and the standard deviation are the expected or true deviations. The population variance is calculated using the population mean, and the general formula is the sum of all the terms xi minus the population mean squared divided by the number of terms, or the number of observations. Now the population standard deviation is simply the square root of the population variance. So this is the population standard deviation. Now the variance of a sample is defined slightly different. The sample variance and standard deviation is how much each individual measurement deviates from the sample mean. The general formula is S squared, the sum of all the terms in the sample, xi minus the sample mean squared divided by the number of terms minus 1. So again, to calculate the sample variance, we first find the errors of all the measurements, that is the difference between each measurement, x, and the sample mean. We then square each value and add them all together. We sum them all and then divide by the number of samples, n minus 1. The sample standard deviation now is simply the square root of the sample variance, and is denoted by S, and that's the sample standard deviation. So let's take a quick look at a couple examples, and actually these examples will show us how the sample and the population standard deviation and variance are different. So let's determine the variance and standard deviation of a population consisting of the 4 observations 1, 3, 5, and 7. The first thing to recognize here is that we are working with a population, so we need to calculate the mean of the population, which is simply 1 plus 3 plus 5 plus 7 divided by 4. And we get that the mean of the population mean is 4. Now we can just plug in all the known values into the formula to determine the variance of the population. But before we do that, we need to determine all the terms xi minus 4. So our first term is 1 minus 4, which is equal to 3. Our second term is 3 minus 4, which is equal to negative 1. Our third term is 5 minus 4 is equal to 1. And our last term is 7 minus 4 is equal to 3. So all we need to do is sum all those up, square them, and divide them by the number of observations to get the variance of the population. So we got, this is negative 3. We got negative 3 squared plus negative 1 squared plus 1 squared plus 3 squared divided by 4, And we just calculate that out and find that the variance is going to be equal to 5. And the standard deviation at this, the population standard deviation is simply just the square root of that, which is the square root of 5. So let's just remember that. This is the population variance and standard deviation. Now let's carry on the same example, but say that we choose the same 4 observations out of a population, so they become a sample. It's not the entire population. So we have the same 4 observations, which are 1, 3, 5, and 7. And we want to determine the sample variance and standard deviation of these observations. Now this problem is handled exactly like the last, except that we use the formula for calculating the sample variance, which is once again sum of all the errors of the term squared minus the number of observations minus 1. So let's go ahead and determine all of these values, all the errors. We got xi minus x prime, and the sample mean is going to be the same, 4. We just add up all of our samples and divide by 4. So we got 1 minus 4, 3 minus 4, 5 minus 4, and 7 minus 4. So we find that xi minus x prime squared is equal to 9, 1, 1, 9. So take these values and throw them into our equation here. We got 9 plus 1 plus 1 plus 9. Divide that by n minus 1, 4 minus 1. And we find that the sample variance is going to be equal to 6.67. Now recall last time when we were looking at the population, here, we saw that the population's variance was 5. And now using the same observations but just dealing with a sample, we have a sample variance of 6.67. So that's how it's different. Now the standard deviation is simply just the square root of the sample variance, which is equal to the square root of 6.67. So that's all I got for you guys today. A quick review of measures of dispersion and how the sample and population variance and standard deviation differ. And so that's very important when you're doing a problem on the exam. Just confirm whether you're dealing with a sample of data or if you're dealing with the entire population as a whole, because the answers will be different. So that's it for now. Head on over to EngineerInTrainingMA.com and shoot me some feedback. Let me know how I'm doing on these, if I'm helping out. If you guys have any suggestions or any requests, go ahead and either contact me through the contact form or sign up for my free EIT preparation bootcamp and contact me through that. Either way, we'll be talking soon. All right, take care. Bye.